Lesson 13, Polynomials, Roots and Coefficients. Now here's the theory. We take this quadratic equation, ax squared plus bx plus c equals 0, and if alpha and beta are the roots of this equation, then alpha plus beta equals minus b on a, and alpha beta equals c on a. Now we'll prove this result. First of all, we take this first equation and divide throughout by a, and we're going to get here now x squared plus b on a x plus c on a equals 0. Now because alpha and beta are the roots, this equation can be written as x minus alpha times x minus beta equals 0. Now removing those brackets, we get x squared minus beta x minus alpha x plus alpha beta equals 0. Now taking out the x, the common factor here, and the negative sign, we get x squared minus alpha plus beta x plus alpha beta. Now these are identical equations. So we'd say therefore x squared plus b on a x plus c on a must be identically equal to x squared minus alpha plus beta x plus alpha beta. Now equating these parts, we can see that the coefficient of x here, b on a, must be equal to the coefficient of x here, which is minus alpha plus beta. Of course, multiplying both sides by -1, we get the result that alpha plus beta equals minus b on a. And of course, the constant term, c on a, must equal alpha beta. Therefore, we can say alpha beta is equal to c on a. Right, now in example 13, if alpha and beta are the roots of 2x squared minus 6x plus 3 equals 0, find the value of alpha plus beta, and alpha squared plus beta squared. The first couple of parts are fairly easy, fairly straightforward. Right, we know that a, the coefficient of x squared is 2. We know b, the coefficient of x is minus 6. We know that c, the constant term, is 3. Formula for part 1, alpha plus beta is equal to minus b on a. So it's minus -6, which is 6, over 2, which is 3. The second part, alpha beta is equal to c on a. Now c is 3 and a is 2. So it's equal to 3 on 2. Now to get this part here, we have to do a little bit of manipulation. Now if you recall that alpha plus beta all squared is equal to alpha squared plus 2 alpha beta plus beta squared. So if I subtract 2 alpha beta from both sides of this equation, I get the result that alpha plus beta all squared minus 2 alpha beta equals alpha squared plus beta squared. Now alpha plus beta we know, and alpha beta we know. So it's just a simple matter of substituting those values in, and we get alpha squared plus beta squared is equal to, putting the 3 in, that'll be 3 squared minus 2 times 3 on 2, and that gives me 9 minus, these 2's cancel out, 3, which gives me the result 6.